Alright gang, this is the sample test review for Chapter 4, Integrated Math 1. So here we go, getting ready for the test. The first two questions want you to find the slope, alright, of the line by counting the rise and the run. Remember that slope is rise over the run, which is like the vertical change divided by the horizontal change. So when you look at number 1, I'm going to start here. And I'm going to first count my rise. Remember, the rise is up or down. So to go from this point to this point, I'm going to go up. Now watch how I count, because here's where you start. 1, 2, 3, 4, 5. So that's how much I have to rise in order to eventually get to that point. So once again, you start counting like this, which is 1 square, 2, 3, 4, 5. So my rise was up 5. That's a positive 5. So again, 1, 2, 3, 4, 5. And then I'm going to go to the right. 1, 2, 3. So that's a positive 3. So it looks like my rise was positive 5. My run was positive 3. Remember, it's rise over run. And so there's my slope fraction. Does that divide clean? Does that reduce? And the answer is no. So the answer is just 5/3. Number 2, let's go from here to here, and so my rise is up or down. So this would be down. Now watch how I count and where I start counting. Watch. 1, 2, 3, 4, 5, 6. So since I went down, that's a rise of -6. So once again, 1, 2, 3, 4, 5, 6 down. And then I'm going to go to the right. 1, 2. And so that's a positive 2 for my run. So rise, run. And that fraction just simply divides clean. -6 divided by 2 is just -3. Making this -3 over 1 wouldn't be wrong or anything, but -3 over 1 is just -3. So I mean, look, that's a huge concept, right? Slope is rise over run. So let me check something out here quick. Well, so we can probably make this a little bigger, eh? In live time. Why not? Alright, now I will do it. Find the slope of the line containing the given points by using the slope formula. So here it is. Here's the slope formula that's on my wall and everything like that. At least these days it is. So number 3, remember both of these points go x, comma, y. X, comma, y. It's just that this is our first x, and our first y, and this is our second x and our second y. So as far as now plugging that into the formula, looks like that's going to be 6 minus 3, boom, minus 3, and then on the bottom, 9 minus 7. And so this becomes 6 minus 3 is 3, 9 minus 7 is 2. Does that divide clean or reduce at all? Nope, so that would be my final answer. And you want it, again, slope is pretty much always best as a fraction. Or like a clean integer, like 5 or -2. But, so 3 over 2. I guess what I'm kind of saying is I shouldn't see answers like 1.5. It's not exactly wrong or anything, but considering that, you know, multiple choice tests are most certainly in your future, keystones, SATs, whatever, I mean, that's what you're going to see. You're going to see 3 over 2 in the answers that you got to pick from, not 1.5. Same thing for number 4. This is my y2. This is my y1. This is my x2. This is my x1. So it's 8 minus -2. Remember, there's a minus in the formula, and if x sub 1 is negative, then it's minus minus. And so -1 minus 2 is -3. 8 minus a -2 is just like 8 plus 2. And so 10. Does that divide clean or reduce? No, so your final answer is just -3/10. Okay. Identify both the GCF and the LCM. Well, duh. Kind of help you out there, don't I? With answer spaces for both. It reminds you that you got to find both. You know, that the direction said that. Anyway, so how do we do this? Well, quick reminder that GCF stands for greatest common factor, and LCM stands for least common multiple. You have, look, if you've gotten this far, well, I mean, we're about to take the test in the class, right? And going into the test, you absolutely need to understand the difference between the word factor and the word multiple. But here's basically what you do to answer these questions. What we've been doing in class in 2018 is looking at the numbers. And, you know, let's start with GCF. You know, you're thinking, what's the GCF of 15 and 6? Now, you might be someone that can just know that in your head. Like, you're very good with numbers and your times tables and just factor, you know. Like me, for example, I can look at 15 and 6, and I can come up with like the greatest common factor of those numbers like that. Some people might have to actually list all the factors, like 1, 3, 5, and 15, and then list all the factors of 6, 1, 2, 3, and 6, and then, you know, with them written on the paper in front of them, and they can like just look at all the numbers right in front of their eyes. They can look and see like which number, like what's the largest factor that they both have in common. You know, and we can look at this really quick and see that it's just 3. You know, so the GCF is actually, 3. But the other way to do this is to make a prime factor tree. Like so. So 15 I can break down into 3 times 5, and that's it, people. Wow. So the 3 can't be broken down anymore in a way that counts. And the 5 can't be broken down anymore in a way that actually counts. Because, 3 and 5 are prime, basically. And then 6 can be broken down into 2 times 3. And again, that does it. 2 is prime, 3 is prime. So 15 is 3 times 5. And more specifically, 3 to the first, 5 to the first. And 6 is 2 to the first times 3 to the first. Okay? And remember, for a GCF, you pretty much take the lower power for each base. It's a little more clear when you get to the letters, you know what I mean? Like you got x to the second and x to the fourth. Which one's going to go in your GCF? Well, the smaller power, x squared. You got y to the first, technically, and then y to the fourth. Which one goes in your GCF? And for GCF, you go with the smaller of the exponents. But you can also do it with these numbers. So when we compare the 3's, we have 3 to the first and 3 to the first. Which one's going to go in the GCF? 3 to the first will. Okay? Now we got to compare the 5's. This one has 5 to the first. This one has no 5 at all, which is technically 5 to the 0. Okay, but you don't really need to write that. So which one's smaller? Well, no 5 at all. So guess what? No 5 at all goes in the GCF. But then there's also the 2's. This one has 2 to the first. This one has no 2 at all. So what goes in the GCF? No 2 at all. Right? And then again, now we do the letters. Now we do the x's. And we already said that the smaller one was x squared. And then comparing the y's, y to the first, y to the fourth. The smaller one is y to the first. And then comparing the z's, you have z to the third and no z at all. So what goes in your GCF is the smaller one, which is no z at all. In other words, z to the 0. You could say that this has, you know what I mean? But you don't need to actually write that down. And so 3 to the first is 3 x squared y. So it was. So like we already saw, whether doing it in your head or from listing all the factors and then just comparing the two lists, or doing this prime factor tree business, you can see that the GCF is 3x squared y. Now LCM is kind of like the opposite. We're going to compare all the bases, and everyone's going to do that with the letters, and go with the larger of the powers for the z's, for the y's, for the x's, and possibly also the 2's, the 3's, and the 5's. Even though a lot of people can just look at 6 and look at 15 and just kind of figure out the least common multiple in your head, or maybe even just list them out. Like for 15, listing all the multiples would start with 15, and then 30, and then 45, and then 60, and then actually keep going forever. But those would be like the start of a list for all the multiples of 15. And then for 6, it would be 6, 12, 18, 24, 30, 36, and then, keep going forever. So, but then you like compare those lists and think, okay, what's the least common multiple? What's the smallest multiple that they both have? And you're going to see that it's 30. Okay, so we know already that by doing this method, that the LCM of 15 and 6 is going to be 30. But if you do it this factoring tree way, you're just going to go with the larger of the exponents for the 2's, the 3's, and the 5's. So comparing the 3's, we have 3 to the first, 3 to the first. It's a tie, so 3 to the first goes in the LCM. Let's do the 5's next. We have 5 to the first versus like no 5 at all. Which one's bigger? Well, it looks like 5 to the first is bigger. And then as far as the 2's go, same kind of thing. We have 2 to the first over here. No 2 at all, like 2 to the 0 over here. Which one goes in the LCM? The larger one, so 2 to the first. And now the x's, y's, and z's. X to the second, x to the fourth. The larger one goes in your LCM. Y to the first, y to the fourth. The larger one goes in your LCM. And then z to the third, no z at all. The larger one goes in your LCM. And so 3 to the first times 5 to the first times 2 to the first. There's your 30. Fourth, z to the third. And so that's your final LCM. So in conclusion, right, you take, like to find your GCF, you do the GCF of the numbers, however it is you do it. There's different methods from listing them, whether in your head or on paper, to doing this like prime factor tree method. But the bottom line is you find the GCF of the numbers and put it in there, and then you do the GCF of each variable, x's, y's, and z's, separately and put them in the final GCF. Same with the LCM. You do the LCM of just the numbers, the coefficient numbers, and put that in your LCM, and then you do the LCM of the x's, put it in, the y's, put it in, the z's, put it in. And I guess one more thing to summarize, just because you got to remember this. For the GCF, when you're working with bases and powers, for GCF you go with the smallest power for that base, and for the LCM you go with the largest power for that base. Now on to this stuff. Graph the following lines on the coordinate plane. Well, hey, this is good news. This equation happens to be in y equals mx plus b form, which means the number in front of the x, that's my m, that's my slope, and this number at the end, added or subtracted on, is my b, and so my b is minus 2. And with that information, I can draw my line like that. I begin with b being my y-intercept, and so if my y-intercept is negative 2, that means my line is going to cross the y-axis here at negative 2. And then I move with m. So my slope, my rise over run, looks like from the point, people, from the point, I rise 1, positive 1, and run positive 4 to get another point on the line. So again, I begin with b, my y-intercept, and then I use my slope, my rise of 1, So this is my rise over run. Up 1 over 4, boom. And I can even like go in the other direction just to make sure my line maintains that slope. And just like that, I'm done. That is my line for y equals 1/4 x minus 2. It has a slope of 1/4, and it has a y-intercept of -2, right there. Same thing for number 6. It looks like my m is -3/5, and it looks like my b is +3. So again, I begin with b, my y-intercept here at 3, and then my slope is -3/5. What you want to do is you want to put this negative only with the numerator. So think of it as a -3. Oh, come on, you stupid pen and board. So think of it as a -3 divided by a +5. So that means my rise is down 3, and my run is +5, so to the right 5. So down 3, right 5 for a -3/5 slope. Remember, negative slopes should be downhill anyway. See how this is going downhill from left to right? So again, this means down 3, so it's like -3, +5. That's number 2. Number 7, the m. So when we have y equals mx plus b, y equals mx plus b. Remember, m is the number in front of the x. It's not the x, it's the number in front of the x, which it's invisible, but it's a 1. And my b value is 2. Okay? And so really quick, I mean, I begin with b. Begin with b, get it? B, 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 b. Begin with b. So that's my y-intercept. Now my slope is 1. Like what does that mean? Like what's my rise and my run? Well, so is 1 a fraction? It is, especially when you just put it over 1. If you have just an integer number, you can turn it into a fraction just like that by putting it over top of a 1, okay? Because anything divided by 1 is itself. So now I know what not only my rise is, my rise, but also my run. Slope is rise and run, okay? So that means +1 for my rise, +1 for my run. That's up and right. So up 1, right 1, bam. Might as well do it again. Might as well do it again. Might as well do it backwards. So that my line is super straight, maintaining its slope, passing through all the proper points, even though it's just a sketch. But yeah, so this line has a y-intercept of 2 and a slope of 1. In other words, 1 over 1. All right? Number 8, looks like my m, the number in front of the x, is obviously 3, which again is going to be -3 over 1 to make sure it's not only rise but also run, rise over run. But what's my b value? I don't see anything there. Well, that means it's 0. And so my y-intercept, where on my y-axis? Well, there's 0 on there it is. My y-intercept is 0 right there. And then my slope is -3 for the rise over a +1. So -3 means down 3 from the point, from the y-intercept, and then over 1. I might as well put a dot there too. And, oh, I do not like that one bit. Let's try, whatever. Good enough. So again, this number here in front of the x was a 1 for m, and the b was 2. Here, m was -3, but in a way, this was like plus nothing, plus 0 at the end. Graph the given line. Well, you need to know what makes these special. If a linear equation only has a y variable, if a linear equation only has an x variable. See, normally there's both x and y in your equation, but if an equation only has a y variable, then it's horizontal. So this is a special case kind of a line, a special case equation, and what's special about it is that it's horizontal. Okay? Just like over here, when the equation only has x, then it turns out to be vertical. Okay? And before I forget, that's where this memory trick, this acronym sort of thing, comes into play. HOIVUX. So if you can remember HOIVUX, you can remember that horizontal lines, the equations are only like y equals something, and vertical lines, the equations are only just x equals something, like x equals -2. And the u actually means something as well. The u means that the slope is undefined. Like the slope doesn't exist. There's no slope, or undefined slope. And this O is not really even an O. So here, this was about the slope of a vertical line. This also refers to the slope of the line. What's the slope of a horizontal line? That's right, it's 0. And so this O is actually a 0. So again, just to kind of summarize this really quick, horizontal lines have a slope of 0, and the equations are just y equals a number. Vertical lines have an undefined slope, or no slope at all, and their equations are just x equals some number. So to graph them, it's very simple. Y equals 3, it's going to be horizontal. You go to y equals 3, so you go to 3 on the y-axis, and you draw your horizontal line. That's it. That is it. So this is going to be a vertical line for VUX, V-U-S. So you just go to -2 on the x-axis. You go to x equals -2, and that's where you draw your vertical line. And it's that easy. So horizontal at y equals 3, vertical at x equals -2. A couple more quick ones the same way. You might want to pause the video, please, and try these on your own. And I will do these in 5, 4, pause the video, 3, pause it, 2, last chance, 1, 0. Here I go. So this means it's going to be horizontal. So I go to y equals -4. So on the y-axis, y equals -4. And I draw that horizontal line, and that's it. This is going to be vertical. I'm going to go to x equals 1 and draw my vertical line. HOIVUX. Number 9, find the linear equation using y equals mx plus b, and that when necessary. Let's just say that our final answer can be in that form, but the way I'm going to do this problem here on this video is I'm going to start with this form, because what they gave me was a point and the slope. And so I'm going to use point slope form. Get it? This is called point slope form because what you plug into it is a point and the slope. Again, the point goes in for x1 and y1. x1, y1, x1, y1, x1, y1, y1, x1, x1, y1. And you plug in the slope for the m. And so we already have all the stuff for free. It's there, just that's right here. So I'm going to plug in 5 for y1, and I'm going to plug in nothing for the y. Like, okay, that's what you do. You don't plug in anything for the regular x and the regular y. But I'm going to plug in the y value of my point in for y1. I'm going to plug in -6 in for x1. And what I'm going to do next here is I'm going to plug in 1/3 for m, because m means slope. I'm going to plug in nothing for the regular x. So minus, and then x1 is another minus, so -6. All right? Which pretty much is x plus 6. Minus is plus. And so I'm going to do my final answer in this form, which means I have to clear the bubble and eventually get y by itself. So y minus 5, then 1/3 times x is 1/3 x, and then 1/3 times 6 is 2. Not going to go into reteaching you about fractions right now. Your calculator can probably do this. 1/3 times +6 is 2. And then the only other thing I have to do is just get the y by itself by adding the 5 out of there. And that's going to do it. So I'm just going to go right to my final answer box. Y is by itself. The other side is 1/3 x. And then +2 plus 5 plus 7. And that's how that cookie crumbles. This is the same exact kind of question. They gave me the ingredients that I need for this formula for free. y1 is 2, so that's y1. My m is -1/2, and my x1 is 8. And I'm going to just solve for y, clear the bubble first, okay? Distribute the -1/2. -1/2 times x. -1/2 times a -8. Negative times a negative is a positive. And -1/2 times -8 is +4. And now I just have to get y by itself, and that'll be -1/2 x plus 6. This is the same basic strategy. If I want to make an equation, I'm going to use this formula. But to plug into this formula, I need a point, which I have 2 points. So I got an extra point. I got a point and one extra. But I also need m. Oh, they didn't give me the m for free. That's okay, because if they gave me 2 points, I can find the m myself with this formula, which you should be very familiar with at this point in time. And so here I go. I can just find the m on my own off on the side. So y2 minus y1 over x2 minus x1. 1 minus 3 is -2. 3 minus 1 is +2. So this divides clean, and so my final m is -1. Okay, now I have everything I need to plug in for m, x1, and y1. Now my m is definitely going to be -1. For my point, x1, y1, I could actually pick either one of these. But like I said in the lesson, at the time when we first learned this, we just got done calling this point x1 and y1. Like over here, we literally we just did this, and we called this our x1 and this our y1. So let's just use that point. We already named this y1, so that makes a lot of sense, right? So there's my y1, bam. I had to work a little bit for my dinner here. I had to work for my slope, but it was -1 now goes in for m. Nothing goes in for x, just like nothing went in here for this y. And my x1 is 1. And just, again, same stuff over and over. Let's clear the bubble and then get y by itself. So -1 times x is -x. -1 times -1 is +1. And then I have to add 3 to the other side to get y by itself. -x plus 4. Next. Another one of these. It's going to be the same song and dance. y2, y1. So 1 minus 7. x2, x1. One minus 7 is -6. -6 minus 3 is -9. This reduces, first of all, negative divided by negative is positive, and this reduces to 2/3. And so now I have what I need to make myself an equation by plugging in to good old point slope form. Once again, I might as well just use this again as my x1, y1. So I didn't like that. Plug in nothing for y. Plug in 7 for y1. What was my m? 2/3. Plug in nothing for x. Plug in 3 for x1, and away I go. So distributing the 2/3. Y minus 7, just hold on a second over there. 2/3 times x. 2/3 times -3 is -2. And then when I add 7 to both sides to get y by itself, the right side ends up being 2/3 x plus 5. And just like that, I'm done. And so that's what is expected to know. Those are the types of problems you're going to be able to do on the test. So happy studying.